Welcome to Setting Course, an ABS podcast where we're charting the future of the marine and offshore industries. I'm Brad Cox, and I'll be your host today. We have another great episode lined up for you. As industries and governments around the world look at reducing their emissions and shoring up energy security, hydrogen has emerged as an interesting prospect for a zero-carbon energy source. An important component of the resulting value chain is the transportation and storage of the fuel, particularly on board ships. Joining us to discuss hydrogen, the value chain, and the shipping industry's place in all of it is Martin Carolan, Managing Director and CEO of Provaris Energy. Provaris is a developer of integrated compressed hydrogen projects for export to regional markets. Thank you for joining us, Martin.
Thank you, Brad. Great to be here.
I'm also pleased to have ABS Director of Global Sustainability, Stergios Stamopoulos, back in the studio today. Thank you for being here, Stergios.
Thank you for having me, Brad. Nice to be here.
And it's also great to have a new voice on the podcast, ABS Senior Sustainability Engineer and Global Hydrogen Lead, Ibrahim Muritala. Thank you for being on the show, Ibrahim.
It's a great pleasure to join you. Thank you.
Let's get started here. Alternative fuels and energy sources have been and will be a long game. Technology, infrastructure, supply, all of that takes time. So, Martin, with so much being invested, where does hydrogen stand today? And how does the industry balance near-term ambitions while still building toward a hydrogen future?
Yeah, thanks, Brad. I think it's important to remember where we're starting and as to where we want to go, because today, while there's some 90 million tons of hydrogen produced globally, most of that is produced and consumed on site. So I think it's less than 3% of global production today is shipped in some form. And then the other factor here, you've got this transition from what is grey hydrogen to this low carbon ambition. So that's going to require significant new investments and new technologies and new ways, and not just one. There'll be alternate pathways for storage and transport. As markets like Europe, where we're focused, they have been net importers of energy for some time and will continue to be, and that's going to be the same case for hydrogen. So I think it's important that the industry looks at various alternatives. We are working closely with utilities around offtake in Germany specifically, and they are looking for multiple sources of supply, multiple technology platforms, and they want to have a portfolio approach. So I think that opens up lots of opportunities for different technologies and different providers.
It's Stergios, from your view, where does hydrogen stand today? And, how do we get to, kind of the really ambitious future for hydrogen?
Brad, I will echo what Martin said. Hydrogen is gaining momentum, but we also need to look at the maritime investment, which is still in its infancy, if I may say. Governments are stepping in with incentives such as funding, tax breaks, and regulations to accelerate hydrogen adoption. The way I would look at it is that investing in hydrogen requires major capital, and there's still uncertainty around fuel availability, infrastructure readiness, and the regulatory frameworks, which is always very dynamic. So the industry, I believe, has to take a phased approach, using existing lower carbon fuels now, while investing in the infrastructure that will make hydrogen viable in the long run.
And Ibrahim, obviously as Global Hydrogen Lead, you're closely entwined with all of this in the industry. So how do you see this playing out?
Basically, when we look at the investments from the maritime angle, when it comes to hydrogen, we notice that hydrogen lags behind when we compare hydrogen to other alternative fuels like LNG, ammonia, methanol, and others. So it's important we look into a kind of transition process itself in the adoption of hydrogen, because there is a lot of investment decisions that requires a kind of holistic approach in terms of balancing technology maturity, environmental performance, regulatory requirements, as well as economic viability across a wide range of other alternative fuel. So hydrogen is still at a kind of early stage because it requires a lot of other logistical consideration, which will really allow us to adopt hydrogen quickly. But it's a process. We are getting there. We've seen a lot of build-up from the knowledge from LNG. And I think what we should have now is a kind of gradual adoption.
So you guys talked a little bit about that economic viability, ramping things up, ramping up production. It's one hurdle to getting things where we need it to go. But really, what are the technical and operational and safety challenges that the industry must overcome in terms of storage and handling in maritime transportation? Martin?
Yeah, thanks, Brad. I think what we've been doing in our development, which we've been going since 2020, 2021, we started working with ABS as a classification society back in 2020, dealing with them on our intentions of design and containment. So safety has been absolutely one element of focus from the outset. Hydrogen has been around for decades. We use compression in the way in which we store in gaseous form. That's been around for decades, but in the context of scale of storage, that is new. So we've had to work closely with ABS in particular through AIP and then the latter stages of a feed design approval, making sure that the focus is not just been on technology or design, but it's been on hazard studies around catastrophe, explosion, all those things. So we've been working on the basis that handling is imperative from day one and trying to minimize the amount of leak points. For example, you have one inlet and one outlet, for example, on our closed system. So I think that's been one of the major hurdles we've had to overcome just to ensure there's acceptance of systems at this scale.
And I'm glad you mentioned the AIPs and stuff like that. Stergios, from the perspective of the class societies, what are those big challenges from a technical, operational, safety that have to be overcome to really help the industry get where it needs to be?
So, Brad, there are a couple of things that classification societies are looking at. First of all, there are certain engineering challenges by the nature of hydrogen as a molecule. So that ranges from low energy density to high flammability and so on. So classification societies like ABS, we are working closely with the industry. Martin and Provaris is a very good example in looking at all these challenges, working with them to provide, setting up safety and operational standards. Also, we try to work with not only the vessel itself and the operators or the owners, but also with the value chain, the infrastructure, ports, bunkering of hydrogen is a big thing. And in general, the role of ABS is supporting also research and development around different hydrogen-related technologies.
And Ibrahim, what about from your view? What are those big challenges that have to be overcome, and how can we overcome those?
Well, there's a lot of challenges, but many of them have been well put in place, especially from other industry. So we might have to adopt some method, maybe, for example, from the chemical industry. Some of the key challenges which we might observe has to do with the handling of hydrogen in terms of storage, in terms of transportation, because there is a possibility that this molecule itself could be compressed, could be liquefied, and all this requires different protocol in terms of safety, in terms of management, especially when you talk about bunkering, transport, and the operational use. Especially, this requires some stringent protocols. Some advanced detection system needs to be put in place to ensure that the safety issues are well in place, because at the end of the day, it's a very flammable gas, and we just need to ensure that all the guidelines, the rules are well in place, and engineers and different stakeholders need to be trained so that they could handle these safety issues relating to hydrogen.
So, the challenges around sourcing green fuels is something we've talked about on the podcast before. Martin, how will the global energy industry scale to meet that growing demand for green hydrogen?
I think the industry is going through a very large reset of expectations right now. If you go back to 2020, 21, 22, there was a lot of consultants did studies with no real experience in the integrated approach. They were looking at silos of production, storage, transport, and then receiving. But what we found over the last 3 years, you need to have an integrated view of how the energy efficiency starts at electrons at one end and delivered back at molecules at the other. I think efficiency and cost right now are the things that we really need to focus on in order to get to decisions of investment, which then lead to scale. So, shipping solutions will still need to be proven, but I think we have to come back to what is realistic scale. It also matches demand, the incentives that were spoken about, and regulations. So we have been, aligning ourselves with a modular approach using compression. The technology of compression is proven. The equipment's available off the shelf. I guess it's the containment system within our vessel design, which is new and it needs to be rigorously approved. But I think too many parts of the industry early on focused on replicating the LNG sector, for example. And we know that started at a small scale at some point. So LPG, LNG, it didn't start at multi-million ton trains. It started, 500,000 units as well. So I think the industry has gone through this groundswell of support. There's been some unrealistic pricing and cost expectation set that's shrunk back down to reality. And now we're starting to see the signs of green shoots where demand side is coming and then the supply side is being stimulated through policy. And I think we just need to match where the market will be. And if the industry can start to see firm contracts, FIDs taking place this year into next year, I think we can have a much better run.
And Ibrahim, what do you see as far as how the industry can scale and start to meet that growing demand?
In terms of scaling, there is a lot of obstacles in the way of scaling green hydrogen specifically. As we know of today, majority of the hydrogen that we use majorly comes from fossil, and scaling to have green hydrogen will require a lot of renewable energy in terms of installation. It's also require also have a lot of electrolyzer to be manufactured for this process. And at the same time, the construction in terms of storage, in terms of infrastructure that is required to transport is also a big question. And when we look at the challenges in terms of infrastructure, we know the high cost of production when it comes to green hydrogen is still playing a very big issue. And policy uncertainty is also a big question. And it's important we try to see how we can balance all these bottlenecks and try to see where we can kind of create a pathway for the improvement of high production of green hydrogen and also the supply chain around different demand and supply nexus.
Stergios, did you have anything to add to that?
Just echoing what Ibrahim said, that scaling up green hydrogen is a challenge. There needs to be a huge expansion on renewable energy. And everything that we discuss as its foundation, we need to consider the availability of funds. Someone has to pay for the scaling up. So there are initiatives, regional initiatives on providing the necessary funds. For example, a recent development is the European Commission Clean Industry Deal that also covers hydrogen in terms of launching a hydrogen bank, budgeting about the bank, and start promoting and mobilizer and connecting off-takers and suppliers with financing and de-risking to facilitate the whole hydrogen production scale-up.
And Martin, kind of steering back to you, obviously we mentioned ammonia earlier. Some people talk about ammonia as a hydrogen carrier. So where does ammonia fit into that equation?
Today, the popular model has been to gravitate towards ammonia production because it's a proven way to synthesize and produce the liquid. There are shipping units available today, and some people are betting on that being a growing market and ordering new vessels. But what we've seen here in Europe in particular is that the industrial user predominantly wants hydrogen. So then there's this conversion factor. So you need to land, store that, and crack that back to hydrogen. So there are important pilots taking place. So from an industry perspective, we want this to be successful. But fundamentally, you lose 25% of the cargo through reconversion. So there's a capital and energy intensive process there. There's a timeline of people are unsure of what the pilot success is going to be. So I think what we're suggesting in our approach is that you need to look at moving the molecule at a scale of which matches the regional supply-demand equation. I think that's why we focused on Europe. Some of the bottlenecks we just discussed around availability of RE, the scale of electrolyzer availability, and financing. So the scale of projects we're looking at here, which are less than a gigawatt, they're moving from 2 to 3 to 400 megawatt scale. They seem to be achievable. And in a regional context, it just doesn't make sense to turn that product into ammonia, ship it a short distance, and then convert that back. So that's our view, is to keep it in gaseous form, and you can deliver it at a lower cost, and then let the big scale regions of, is it India, is it Australia, is it the Middle East or the Gulf Coast will produce a lot of ammonia.
Yeah, Martin, so I think you kind of overlapped into our next question a little bit here. Obviously you guys are deeply involved in several green hydrogen projects, particularly around the storage and transportation of compressed hydrogen. So, can you provide a little insight into the work Provaris is doing and maybe some insight into how the industry has progressed on transporting compressed hydrogen in bulk?
Yeah, so first of all, it doesn't exist at scale. So there's been compressed form of hydrogen from a ground transport perspective. You've got providers out there who've had great success using trailers with either pipes or carbon fiber bottles, and that's been a success. That's emerging. We've looked at it from a bulk scale perspective. So we've started with extensive work with class, looking at the tank, integrating with vessel, and then we've then looked at loading arms, we've then looked at compression, and then we've integrated with both generation of electrolyzers and then looking at electrons. So we've been working collaboratively with industry. We could sit back as a shipping industry and wait for it to come, but we've actually gone after it. So we've got supply partnerships here in Norway and the Nordics, and we're looking at Spain, where we're looking at the production side and integrating there. And then we've worked with the 3 German utilities, which we have under MOU. One of those is Uniper, which in January this year, we signed our first term sheet. So that was supplied from the Nordics into the Northwest Europe market. And that's at a scale of 40,000 tonnes, which is around a 250, 300 megawatt scale project. So I think that's the scale of which we've seen in our work that utilities are happy to take on a path to binding agreements. But it's all been about integrating with both supply and end user, which has had the success of us to move forward. We signed our second collaboration here in Norway, and we've actually seen a pipeline of these projects that are 200, 300 megawatt scale, 30 to 40, 50,000 tonnes, depending on utilization in a regional context of Europe. So we're starting to see the emergence of supply matching demand, and I think compression's in a sweet spot to try and take care of that. Some of it will be used as an ammonia project, I'm sure, but it makes sense to use compression.
And Ibrahim, can you speak a little bit to that, compressed versus liquid transport of hydrogen, pros and cons, differences, that kind of thing?
Yeah, thank you. Compressed hydrogen avoids the energy-intensive liquefaction process, which also makes it a little bit simpler and more efficient for short to mid-range transport. However, compressed hydrogen has lower energy density and requires high pressure tanks. Looking into the liquid hydrogen, on the other hand, this has a high energy density and making it suitable for long-distance shipping and other possibilities. But it also requires a kind of cryogenic storage, which also makes it to have some kind of increase in costs, as well as maybe some kind of energy losses. At the end of the day, comparing both also requires one to look into the kind of market that one is serving. So in terms of long distance, in terms of short distance, in terms of mid-range distance. So both have their usability and applicability out there.
So, looking further out, what's the outlook for hydrogen? Will it be, a big piece of the future energy puzzle? Is it a matter of technology catching up to demand before, we can kind of see that happen? Martin, you want to take that one first?
Yeah, I think there's lots of ways to answer this question. Initially hydrogen was seen as what they called it, the Swiss Army knife of solutions. Clearly that's filtering out now. We personally focus on the industrial user set. They have a demand for decarbonizing their energy intensive process. It's not so much the energy source, it's what do they use that fuel for. It definitely has a role to play. We're seeing through this reset that I spoke about, we're starting to see there still is great ambitions by the European industrial market to kickstart. There's commitment from the European Union. There's commitment from federal governments. You've started to see infrastructure be put in place with the TSOs collectively getting together in Germany, defining a plan, and the governments and TSOs financing that plan. So FIDs are now taking place on the pipeline, which is required to service these industrial hubs. So I think there's a lot of good news. I think unfortunately the sector's received a lot of negative news with some large-scale projects. Big Energy's rolled back on some of their commitments, but I think there's still a viable business opportunity, and I think it may be slower, but it's still looking to commence at an industrial scale or bulk scale in that 2028 to 2030 window. That's where we see demand for imports, and so as a shipping provider, we need to make that happen, but also it needs the right level of supply at the right cost.
And Stergios, of course, you've been involved in the ABS outlook over the years. So What do you see as the outlook for hydrogen?
So it's really more of, if I may describe it, the chicken and an egg situation. So the technology is advancing. Fuel cells, hydrogen-ready engines, and improved storage solutions. But we still, at least looking at it from the maritime viewpoint, there is some gaps in the infrastructure to make it viable at a scale. So ports, pipelines, storage facilities all needs major investments, as we previously said. And until those pieces are in place, there's going to be some challenges with relating to hydrogen when you compare it to other alternative fuels or energy sources. So, however, that said, hydrogen will play a big role, especially for industries that cannot easily either electrify or use other energy sources, such as shipping and heavy industries, as Martin previously said, on the European front. But realistically, it won't be something that will happen tomorrow. It will take some time, and there is a need for everybody to work together.
And Ibrahim, any additional thoughts on the outlook for hydrogen?
Yes, hydrogen has been playing a key role when it comes to decarbonization of different economies and different industry. It's going to still be a major player in terms of helping transform excess electricity that will be generating from these renewables, because this is the major way for us to be able to convert from electrons to molecule. It's going to be a feedstock as well as a commodity. So as far as the future trend is concerned and what it's all about, it's going to give us a kind of entire value chain opportunity when we look at the hydrogen economy itself as a big area. Technological advances, it's important. Infrastructural development is key to ensure that hydrogen will continue to play its major role in terms of decarbonizing several sectors like shipping, maritime, and other energy-intensive industry that requires hydrogen. So it's important that all hands must be on deck to ensure that we put necessary opportunities together to allow this work.
Okay, great. Well, to wrap us up, I was wondering if each of you had any closing thoughts you'd like to leave with our listeners. Martin, why don't you take that one first?
Yeah, thanks, Brad. I think two things. One, you don't dismiss the industry needs to start at a scale which is related to both supply, demand, and financeable, right, which is matching regulations. And two is that when you talk to the downstream industrial users, and then there's the traders and the buyers, they want a portfolio of supply sources. I think, regionally, Europe has a role to supply. It will be the main demand center for some time. The US Gulf Coast is certainly taking its place with ammonia facilities building shape. And then the swing volumes will be the bigger volumes that are further away. So I think we need to start regionally and then build out to a global footprint.
And Stergios, any closing thoughts for our listeners?
Final thoughts. Hydrogen is not going to be an overnight solution, but it's a very critical piece of the puzzle. So right now we're in the what I call investment and infrastructure building phase. And while the industry is facing challenges, the momentum is there. So more to come in the very near future.
And Ibrahim, any closing thoughts?
Collaboration between policymakers in terms of regulation and industrial stakeholders, as well as financiers, will be a key part in terms of accelerating the hydrogen economy. And at the same time, when we look at the next decades, there will be a kind of dominance in terms of clean energy, and hydrogen will continue to play a key role in terms of providing technological solution for decarbonization. Because at the end of the day, the purpose of all this is the environmental sustainability. But overcoming infrastructure challenges must be well put in place to ensure that hydrogen will play its role.
Okay, great. Well, anytime we talk about alternative fuels, energy sources, it's always a super interesting discussion. And I think this one didn't disappoint. So, thank you, Martin, Stergios, Ibrahim. Really appreciate you guys being on and being with us for this episode.
Thanks, Brad.
Thank you, Brad, for having us.
Thank you.
And for everybody listening, thank you for joining us for another episode of Setting Course. Be sure to subscribe, leave a review, and share this episode. To keep up with the latest sustainability developments, visit us at www.eagle.org. Thank you for listening.